Okay, so like I mentioned from the last video, the goal is for students to solve multiplication problems using the standard algorithm way. But because the majority of students do not know their multiples, I wanted to share some strategies on how to work with them at home. One strategy is, so this is this week's homework. One strategy is to basically write. So just writing their facts multiple times, and maybe after writing their facts, they can even repeat it out loud. Like 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. So they can quickly eventually memorize it a lot better. And you can do that with all of your multiples. So you can do that with 1s, 2s, 3s. 5 times 1 is 5. 5 times 2 is 10. You can do that with the 9s. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. All the way up to 12. Okay? Another strategy that you can work on with them at home is the input-output strategy. So for example, if you wanted to teach your child multiples of 8, let's just say that, what I'm gonna do first is I'm gonna draw 8 dots on top. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to name my table the times 8 table, and then create my little input output chart. So I'm gonna put 1, okay, and then count my first set of dots. So that's 8. So I'm gonna put 8 right here, okay. 2. So now continue on from 8. 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, let's do 3. 16, 17, 18, 19, 20, 21, 22, 23, 24. And when they keep using this table consistently, they're gonna make a connection that 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, and 4 times 8, 24, 25, 26, 27, 28, 29, 30, 31, 32. Sometimes students don't have to memorize their multiples just yet, but knowing how to create this times table will help them solve their problems using the algorithm strategy. So for example, if I wanted to do 5 times 3, I can create a times 5 table. So I can go, okay, 1, 2, 3, 4, 5. And then I know that it's going to be my times 5 table. And then I can quickly make a little chart. Okay, 1 will be 5. And then 2 would be 10. And then 3 would be 15. 4 would be 20. So the question says, what's 5 times 3? So I'm going to go back to my table and say, oh, 3 times 5 is 15. Okay, 15. Then I can say, okay, then what about 4 times 3? Create a times 4 table. 1, 2, 3, 4. Okay, 2 is 4, 5, 6, 7, 8. 3 is 12. So 4 times 3. So I'm going to look at my times 4 table and see that 4 times 3 is 12. So this can also be another strategy to use when solving algorithm format instead of doing pictorial.